In this video tutorial, we will show you how the robots are controlled with C. Okay, then let's move on to the show. What is our first step? Brief description about hardware components of the robot, main role of those components, how those components are integrated, pseudocode of controlling, C code, complete demonstration. This is what our robot gonna do according to the C code. Find the box, move towards the box, grab the box, move the box to a predefined position. These are the main hardware components which we need to build our robot. Peripheral interface controllers, sensors, position sensors, light sensors, digital to analog converters, servo motors, microcontrollers, 18-pin enhanced flash. Peripheral interface controller. Peripheral interface controller is an integrated circuit which is developed to control peripheral devices lighting the load from the main CPU. Compared to a human being, the brain is the main CPU and the PIC is equivalent to automatic nervous system. The PIC is convenient for making calculations. The memory, input-output ports, and so on are incorporated into the integrated circuit. The efficiency and the functions are limited, but the PIC can do the job of many ICs with software, so the circuit can be compact. How PIC is working? The PIC, like the CPU, has calculation functions and memory and is controlled by the software. However, the throughput and the memory capacity are low. Depending on the kind of PIC, the memory clock operating frequency is about 20 MHz and the memory capacity is about 1 kilo to 4 kHz. The clock frequency determines the speed at which a program is read and an instruction is executed. The throughput cannot be judged with the clock frequency alone. It changes with the processor architecture. However, within the same architecture, the one with the highest clock frequency has the highest throughput. We use a 14-bit word for program memory capacity. This is a sample circuit diagram of a peripheral interface controller. Sensors. Sensors are the most important part of a robot. Using the sensors, the robot can identify things and changes of the environment. A sensor is a device that measures a physical quantity and converts it into a signal which can be read by an observer or by an instrument. For example, a mercury in glass thermometer converts the measured temperature into expansion and contraction of a liquid which can be read on a calibrated glass tube. A thermocouple converts temperature to an output voltage which can be read by a voltmeter. For accuracy, all sensors need to be calibrated against known standards. A sensor sensitivity indicates how much the sensor's output changes when the measured quantity changes. Sensors that measure very small changes must have very high sensitivity. In our robot, we use lighting sensors and position sensors. The position sensors used to identify the position of the robot and find the shortest path. Also, the lighting sensor used to identify the objects. A position sensor is any idea that permits position measurement. It can either be an absolute position sensor or a relative one. Position sensors can be either linear or angular. Some position sensors that available in present are capacitive transducer, rating sensors, eddy current sensors. A light sensor is a mechanical or electronic equipment that detects light. It is used to provide information on distance, shape, speed, dimensions and even types of substances contained in a wide array of objects. Within